Here we're going to look at question 15 from section 2 of the BMAT 2014 paper. So in this question we're given a cooler which is made up of a container around the outside, some water inside it, and then there's a cooling unit in a position P, Q or R. So we're told that this cooler is kept in a room at room temperature of 20 degrees C, and that initially the cooling unit is turned off, so the water is also at 20 degrees C. Then the cooling unit is turned on, and we want to try and get the water down to a temperature of 5 degrees C. So the question asks us to cool the water as quickly as possible to this temperature. Should the cooling unit be at position P, Q or R? And should the container containing the water and the cooling unit be dull or shiny? So if you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go at it together. Okay, so to go about answering this question, let's begin by thinking about the position of the cooling unit. It could be at either P, Q or R. But what's the difference actually going to be? Well, what our cooling unit is going to do is it's literally going to cool our water down around about it. And what do we know about cold water? Well, it's denser, so it's going to sink. So if we cool some water, then it's going to move down in our container and it will be replaced by some warmer water. So if we were to put our cooling unit at position R, then it's just going to cool the water around the bottom. And since this is already at the bottom of the container and the cold water is just going to get denser, then the water is just going to stay at the bottom of the container. So the cooling unit will eventually cool the rest of the container, but it's not going to happen as efficiently as possible. What will really have to happen is the water around about R will just have to get colder and colder and colder, which should essentially transfer some of this sort of coldness or take the heat away from the warmer water up above. But it's not going to be the most efficient way of getting the container down to 5 degrees C. It'll get some bits colder than others. Anyway, moving on, we can look at position Q, and in which case this is going to keep some cold water around about Q, and when this gets colder, it will move down and be replaced by warm water at the bottom of the container. But the warmest water up here at the top of the container will just stay here. It's not going to move at all, so it's going to have a similar problem to R in that the warmest water is going to take a long time to heat up. But if we were to move the cooling unit to position P, then we would sort of have a bit of a convection current set up, shown here. So the coldest water would move down to the bottom of the container and the warmest water would move up. And so it would cycle the water around, cooling it all fairly equally, and it would get all the water down to the same sort of temperature fairly efficiently. So the position we're going to want is actually position P. Now with that in mind, let's move on and look at whether the container should be dull or shiny. So what actually is the difference between the container being dull or shiny? What does it mean? If the container is dull and black, then this is going to be a good absorber. So it's going to absorb heat really well, and it's going to emit heat really well as well. So what about then a shiny surface? Well, a shiny surface is just the absolute opposite. It's a bad absorber. It's really bad at absorbing heat, and it's also really bad at emitting heat. So this is really the difference between it, and it's whether we want our container to be good at absorbing and emitting heat, or whether we want it to be bad at emitting and absorbing heat. So what do we want? Well, we're trying to cool our water down to below room temperature. So really, we want to keep it as separate from the room temperature as possible. We want to keep heat out. So what we're trying to do is stop the container from actually absorbing heat. And now obviously this is just going to correspond to being a shiny surface. So we're going to want our cooling unit to be in position P and our container to just be shiny. And with these both together is just going to correspond to answer B given in the question.